Hello and welcome back to the channel. My name is Lucas, and in this video I'm going to share something that is sort of basic about Python, but that I had missed all along. I've been developing Python for about 10 years, and every now and then there comes a little detail that I had missed, and this one I feel like I should have known. So that's what I'm going to share today. So to start with, let's have a function to play with here. Let's get a function called greet that receives a greeting and a person. It simply prints the greeting and the person. And how to use this function is very easy. So you simply greet with a greeting, and then we give it a person. Let's give it my own name, Lucas. Simple. So now we have a playground here. So in the world of programming, we usually have two different kinds of arguments that we can give to a function. You have positional arguments and keyword arguments. So this function takes two positional arguments, and positional arguments are mandatory. So if I don't send this positional argument here, the function is going to complain. You did not give me all the positional arguments. And their order matter. That's why they're called positional, because their order is important. If I reverse the order of the arguments when I'm calling it, Python's going to think that I'm saying Lucas, hello instead. And then apart from positional arguments, you also have keyword arguments. Let's take a look. If we define this like this, where we give the name of the variable that we're going to use and then a default value to it, that is usually what we call a keyword argument, and the function is going to usually, we're going to see why I'm saying usually so much here, but the function is going to be called like this, as a keyword argument. So the interesting thing here is that in this beautiful wonderland that's called Python, a keyword argument does not always have to look like that, and a positional argument can be optional. Yeah. And there are more things that are like absolutely insanity. So if you're coming from another programming language, brace yourself. There's going to be insane stuff coming forward. So let's get this function back to our original definition where we only had positional arguments. And then let's keep this one like this. Let's see what happened. Is Python going to complain that we have a positional argument being called as a keyword argument? No, we're not. So you might think, yeah, fine, this is okay. I mean, kudos to Python. We can call a positional argument with as a keyword syntax, and things are just going to work. But the implications of this is that the name of the variables in your function definition become part of your API. Let's say you're developing a library that's going to be used by millions of developers because you're a successful developer, and you are creating a function, but you're not quite sure how to name your variables quite yet, but you decide to publish your function. And then people start using your function, and then you change the name of the variables in your function definition. What happens? Let's take a look. So let's say that I wasn't sure whether I was going to greet a person or a customer, and we change this one. And you think, okay, this is a positional argument. Nobody's ever going to think that it's a problem. But boom, you created a problem for all of your users that were using your function like this. So if I were to give a recommendation, don't use this flexibility from Python. Let's stick to your lane. If you're developing a function that's going to be used by other people, do not change the variable names in the function definition. That's part of your API. And if you're a user of an API, try not to call positional arguments as keyword arguments, because that might cause problems for you in the future if the developer of that function decides to change the name. So if we stick to our lanes, things are just going to work. I know that's strange because Python gives us flexibility, and yet we get more constraints to play with. I don't know how to reconcile that in my brain. But what if you're developing a function and you don't quite know the names that you're going to use in your function definition yet, and you want to give yourself the possibility to change in the future? From Python 3.8, there is a way. All they have to do is to add a / after all of your positional arguments. And what happens in this case is that if someone tries to use that word for calling your function as a keyword argument, Python is gonna raise an error here. Do I recommend you to use this / all the time? No. I think it's better to just stick to conventions than to force people to do something. But are there use cases for this? Absolutely. If you're not quite sure and you want to give yourself the freedom to change your variable names, use the /. Another consequence of the forward slash as an argument that was introduced in Python 3.8 is that it gives birth to a concept that is really weird. Let's take a look. You can have a positional argument that has a default value. So the person has a default value of Lucas here. And this continues to work because I'm still calling the function with two positional arguments. This is still a positional only argument. So if I try to do it like this, I still get an error, but now we have positional arguments that are optional. So I have a positional argument that is optional. So if I don't pass the argument in, Python is still happy. I don't think I've seen this anywhere else. Is this useful? I don't know if this is useful. This is like, it's a consequence of the forward slash there that I'm forcing this to be a positional, but like positional argument that is optional. Yeah, Python. But wait, there is more. Let's go back to what we had here. Let's say that person is indeed an optional parameter that has a default value. So what happens if I send a positional argument instead of a keyword argument? So let's remove this. Will that work? In Python Wonderland, you can do everything. You can call keyword arguments as positional, and you can call positional arguments as keyword arguments, and that blurs the line completely between them. Here's the full definition of the thing. Keyword arguments and positional arguments are a blurred definition that you can call them as each other, and it doesn't matter as long as your positional arguments come before your keyword arguments. That's the only rule that you have. Everything else is allowed. But every bit of flexibility gives us a little bit of problem as well. So what is the problem with this? Well, not as big as we had before, because we're not going to break any APIs here if we change names or things like that. The problem here is that the caller of the function is removing clarity from the call, right? So if we had the person here, this would be much more clear which argument is what. And imagine for a function that takes many, many arguments, if you remove the keyword from the equation, it just becomes a mumbo jumbo of arguments being sent in. So as a developer of this function, what if you want to force people to send in keyword arguments as keyword arguments? There is a way. In the wonderful Python Wonderland, if you add an asterisk argument right before all of your keyword arguments, people are not allowed to send positional arguments instead of keyword arguments. So let's see what happened here. We get, boom, an error. Greet takes one positional argument, but two were given. Yeah, so this thing here terminates all of your positional argument, and everything after that is a keyword argument. Now, do I recommend using the star argument for forcing your users to call your function in a certain way? Most of the time, I would avoid that. That's just extra complication in your code. That's extra restriction for your users. And I just don't like forcing people to do stuff. And so much so that when I want to change my function definition, I try to keep the backwards compatibility as much as possible. So in this function, if I want to add an argument, and a very valid case is if I want to call this print function here, let's say that I want to give the user the ability to control the end here. How do we do that? So we could add an argument end here and then pass the end to the end. So now the user can define an end here. And let's say that they want the end to be an empty string. The problem is that if I add an extra positional argument, I am changing my function definition. So users that do not add the end are going to have a problem because they're not sending that required positional argument in. So whenever you want to add an argument to your function, 99.9% of the times, you're going to add a keyword argument with a default value defined. So let's define a default value for this end here. And that is going to be the default that is actually defined in print function. And now users that do not adapt to the new API still have their code working. So do everything you can to not break backwards compatibility. But in this case specifically, the print function takes many other arguments. It takes a sep, it takes a file and takes a flush. And then you might be tempted to send in like this, sep, and then you look into documentation what the default value for sep is. It is a blank space, and then it takes a file, what the default file is, and then you start, oh my god, this is starting to become a little bit unwieldy. The problem is that we're actually wrapping the print function in our greet function. So there is a great way of sending wrapped arguments right down to our function, and that is via this syntax here, ** kwargs. And now all that I have to do is to send in this kwargs in here. So your greet function does not need to know what those keyword arguments are. But let's print them here. Let's see what Python is giving us. So let's print kwargs without the stars. And then let's send some keyword arguments here so that gets populated. Let's say that we want the end to be the same one. No, let's say we want the end to be end, and then we want this sep to be sep. So see what we get here? This is a dictionary. So Python is getting the keyword arguments, wrap it into a dictionary, and sending it to us. When we print this, we get this dictionary. And then when we send it forward, we unpack that dictionary, and that becomes the keyword arguments. And that is brilliant. I love that. I use that every time I wrap a function in Python. And as an added benefit, you also see the function of the sep. It gets printed in between. So whenever I have this comma here, separating two arguments, you also have the sep, and end terminates everything. That's how print functions. All right, so after all this magic, is there anything more that we can do? Yeah. There is more magic that you can do with Python functions. Let's take a look. Let's say you want to greet more than one person. So let's say you have person 1 and person 2. Now we can greet person 1 and person 2. And now we are required to send in 2 people, Lucas and John. I don't know who's John. I don't know who's John. Now we can greet 2 people. But what if we did not know how many people we wanted to greet? How do we do that? Well, there is a way. So instead of saying here explicitly person 1, person 2, person 3, let's delete this. And now before the person, let's add an asterisk. And also let's print this person to see what Python is sending us. And then of course here we are not sending person 1 or person 2, we are sending star person. Okay, so we are unpacking that person. What are we gonna get here? So I'm curious what this here is going to print. We're sending greeting, hello, person star is Lucas and John. So I'm curious what Python is going to print to us here. So let's see. All right, so it looks like we got a tuple. So Python is getting these 2 arguments, packing into a tuple, sending in here. So I have access to this tuple inside the function. And then in here, we unpack the tuple into the print function, and it gets sent as an argument to the print function, as a positional argument. Now, to close this video with a golden key, I'm gonna end with a recommendation. So now you learn this star argument syntax. Don't use it. There are very few cases in which this is useful. And one of the cases where this is useful is when you're passing down these arguments to another function that takes that kind of argument. But in most cases, it's just better to receive the tuple rather than receiving this unpacking version of the tuple. Does that make sense? And the reason is Python is converting the argument into a tuple for you. And you might not want that to be converted into a tuple. What you might be receiving there, it might be a generator that is reading from a file, is reading from the internet, millions of lines, and all of a sudden, all of that is being loaded into the memory of your computer at once. That is a problem that I talk about in depth in another video. I don't know which side it's going to appear, but take a look at that one. I think that video is actually more important than this one, so definitely check it out. And that's it for me today. Hej då!